example. So what we did is we used the Video Ninja Web Sender, and then I built a little website that also can be displayed on an iPad. Because of course, it also works on an iPad. It works on an iPad. It works in my browser, and we also used, like we talked earlier about, Cloudflare for it. So here is our little demo, and to showcase that it's live, we hooked it up so you can just click on any of the pictures. You see it changing, and the Kenai might have saw, this doesn't look like a Blackmagic multi-viewer. That's not the multi-viewers that you often see. It's actually a ROS Carbonite multi-viewer. We're running ROS Carbonite code that we hooked this up to. We can take the NDI output, bring it into WIP, send it off to the server, and then we get it into the website. So you see, if I click here, you actually see it moving on Bo Caudle's panel in Charleston. But this is not it. Since we're talking about integration and I wanted to show how cool it is that like all of this just works together, Jason and I worked on a little demo. We wanted to do something like this when we did NAB, where we had the camera controller, but that didn't fully work out. For some reason, the Apple Vision Pro really didn't like me being in the driver's seat. So as soon as I put it on, it was like, I don't see any Wi-Fi, so you can't connect anywhere. It was on the show floor, so that probably was more the reason. But if we cut over to Jason, and you see he's in his Vision Pro and he has the same website. So he can just put that multi-view wherever, and now he can look at something and do a single pinch to preview it, a double pinch to take it, and then also just touch it. And this is one of the things that I'm really excited about, is why I'm so deep involved with web stuff, is you just have all these options that suddenly work. You can start there, and then you go to a broader platform where you build native applications. But yeah, and if we cut to this again, maybe we can do a 2-up. We will also see that if Jason does changes, they are reflected on my end as well. So as soon as he clicks it, it updates. Yeah.
So he's controlling a hardware switcher, but seeing the individual feeds. Is that right?
So he is controlling ROS Carbonite code, which is running on a PC. We are getting a bunch of Zoom feeds in this case, and we take the multi-view out of that switcher and put it into a WIP stream. So that way we can send him the multi-view.
This is one video, and then you have regions that he can touch.
Yep, and then we just get the little touch point when he touches.
I got to say, this is a little mind-blowing, because Jason is really just tapping the air in front of him on a virtual display in Vision Pro, and it's actually affecting the real world in virtually real time. I mean, this is kind of Minority Report come to life.
Yeah, and when you look at the POV at the bottom right corner, that's where you actually see a live camera shot from Bo. So you see Jason is in his Vision Pro just tapping the air, and that is controlling a switcher in the air, and you can see it reflected on a hardware panel. So that's the demo. If you have questions about that, feel also free to put them in the chat, but I'll do it short. This is a short introduction.
That's fantastic. We got tons of questions. Let's go ahead and jump into the first one.
Grant Whitehead from Adelaide, Australia asks, I need to stream low latency video to web browsers on 6 LAN devices in a venue. What is the best way?
Go ahead, Jonas.
I would use something like OBS, or if you're really offline, I would use OBS and send that to a web server. What you can do there is Media MTX, for example, is a free server you can run on Windows. You can configure it. Reach out to me on Discord and I can help you configure it. And then you just need to host that viewer link. One issue you might run into is SSL and HTTPS, because some of the browsers don't like WebRTC on unsecure URLs. So you might need to do something there. But the great thing is you can overcome all of these and you can disable it. And then you really get super low latency. We have done tests with Nimble Streamer, one of the servers we use in the cloud, where we had someone send a WIP signal to it and then watch the web. And it's the funniest demo to do with people when I introduce them to our system, because they sit in front of it and they're like, so am I seeing like the local preview or like what is happening? Because it's so quick. Because at some point we're only bound to how fast can we get it there and back, especially if we don't transcode it. So yeah, I would do that if you have the bandwidth for it. You could also do NDI, but yeah, I think this is a great solution. Just do it this way. And one of the tips that we do is we use Dashmaster 2K, which allows you to embed, and I'll show you my little embed tool that I built, embed the web URLs in there, and then we can actually remotely switch what our operators see. So at the end of the production, all the multi-views all over the world go to a nice multi-view offline. And I don't need to worry that anybody can see the web view anymore because it just switches out the URL.
Good guy.
Yeah, I'd look at some of the options from Teradek. They have Video Village that uses a lot of these types of scenarios where you just want to attach a cube or some kind of encoder from them and then share that out to either over their Wi-Fi. There's a bunch of diagrams. The technology's changed over the years. There's also really inexpensive RTSP streams that you can get with like that Zowie box that I showed the other day. That thing will push out an RTSP. You just would have people connect to. It has its own Wi-Fi, so it depends on how far away the people are, and if you want to put it on a local area network, if you have that possibility, then you can also use that device as well. I'm not sure where the limit hits. I think it's around 6 users, so that might work out for you. So there's a couple options in hardware.
Yeah, and we're going to start testing some prisms. So stay tuned for that. We've got a prism set that two-way that we're going to test from Teradek. Next question.
Eric Hers in Hartford, Connecticut asks, what bitrate is required to maintain consistent high-quality video with WebRTC?
Jonas?
It really depends on the codec and what you're doing there. One of the great things with WIP is technically it's not required to have any specific codec. You can use any codec you want, but you are limited if you want it to be played back in the browser to H.264, AV1, VP8, VP9. So you do have some modern codecs that you have available there. In generally, our multi-views are around 2.5 megs most of the time, which are good enough. You can tune it up as much more as well, but we found 2.5, 3.5 is probably fine for most multi-views, especially since you have a lot of static. If you have the PowerPoint and all that, we had really good results with that. But generally, it's just a video feed. Like there's nothing groundbreaking that needs more bitrate or less bitrate. But AV1, VP8, and VP9, of course, have a lower bitrate requirement that H.264 has.
Next question.
Bo Cordell in Charleston, South Carolina asks, how does WIP compare to other protocols like RTMP, latency, quality, etc.?
Jonas?
So WIP, and for this case, WIP really is WebRTC. So if we think about RTMP versus WebRTC versus SRT, RTMP can be really fast if you tune it all the way down. WebRTC really is made for the browser, and that is where it comes from, and that's kind of where it evolved from. That's one of the big advantages, is seeing an RTMP feed in the browser still isn't really feasible. So WebRTC really gives you that. Quality-wise, I think you can achieve the same quality most of the time, and most servers that I see, and most services especially, don't support bitrate higher than 6 Mbits most of the time, so you might have a trouble there. But yeah, we have done some really weird things with WIP where we did like double wide 1080p to transmit a screen share and a person at 20 Mbits, and yeah, it's the same quality if you did RTMP. But if you compare it to SRT, one of the important things to note with SRT is that it has send and receive buffers. The minimum required latency for those per spec is 120 milliseconds. So that's the lowest speed latency that you'll get. just because you need those buffers. So RTMP can be really, really quick. And I know that Bo, for example, used RTMP to send to a web server. And it's kind of funny to me when I often hear RTMP is so slow and SRT is so fast. It's just how people look at it. Like most people, when they say RTMP is slow, mean RTMP is slow because till you see it, it is RTMP gets transcoded to HLS, then you see the HLS, then probably is a little bit of a receive buffer. That's why it's slow. But we have, before WIP released, before WIP was widely adopted, we used RTMP all the time to send really low latency feeds to our servers and then get a WebRTC back. SRT isn't built for really low latency that way, but people seem to continually talk about it in that way because that's where they see it point to point, where you can just pick it off directly in RTMP most of the time. You have at least a transcoding step in between.
Next question.
Douglas Carmichael asks, would there be a reference implementation of WIP/web that we could use for testing and learning about the protocol in our own setups?
Go, Jonas.
So one of the great things with WIP and web is that the spec is open, and that there's, if you just search GitHub, you'll find the whole thing. One of the biggest innovators, I would say, for that is Avon. They are a company that has a lot of open source stuff. If you want to look at a player, theirs is basically the standard that everybody uses for web nowadays. They have a little tool called SRT2Web. You can launch it in a Docker container, and that just automatically takes in an SRT, sends out a web feed. It is really simple to use. They even have open source cloud now, where they do open source as a service, where like looking at an SRT feed is as simple as typing it in here. They give you a web feed, you plug it into any player, and you see it. That being said, if you read my article, I think I said there's about like 50 lines of code that you need to do to implement WIP in a browser. If you head over to Cloudflare and search for Cloudflare Stream, they have a reference implementation of WIP from the browser that's like 40 lines of code. If you read through that, you will really learn a lot about it. And that's one of the cool things with WIP and web is how open in the public it has been developed and how many people have been part of it. There's open source software all over the internet. One of the simplest ways to do a broadcast is use Broadcast Box, that is like a WIP web server. That's one of the things I really like is if you have the WebRTC, which you have in the browser, you can have a lot of fun with it.
Next question.
From the QR code, Elias Purunen in London, Canada asks, to use WebRTC today, it feels like you need to use a service like Dolby Millicast, Janus WebRTC, or something else. Is there a simple for dummies one-click way to get going with WebRTC streaming? Jonas?
Yeah, so that is one of the things where WebRTC normally doesn't require a server or turn in an ICE server, but not a server where the data goes through. That is not the case with WIP. You do need a server, but there's all these open source frameworks that you can use. And if you really want to have a really quick and fast thing, there is Broadcast Box that you can self-host as well, but there's also a public instance that you can use where it's as simple as plugging it in and all that. But that being said, if you have $5, what I would do is head on over to Cloudflare and create a Cloudflare Stream. The minimum required payment is $5 a month. And right now, since WIP Web is still in beta with them, it's for free. So we use Cloudflare Stream a lot to send our WIP feeds to it. You create it, and then basically you get two things. You get a WIP URL and you get a web URL, and that's it. That being said, I do know that it's still quite the lift sometimes. So if you look at Avon's OSS AI open source as a service cloud, they have some offerings there, and we are actually working on being able to do the middle control thing that allows you to create and remove those services. But if you have like an evening, you can probably spin up your own little server on a VPS relatively cheap.
Next question.
Eric Hers in Hartford, Connecticut asks, do you think that Quick-based applications will replace WebRTC for non-conferencing use cases like video contribution, large-scale broadcasting, and remote desktop control?
Thoughts, Jonas?
Maybe. We'll see. I mean, I know that Eric Hertz is really excited about Quick. And I think that's kind of like Alex always says, moving the ball down where the receiver will stand. There's also a chance that the person will stand there, but right now it looks like people are not even running into that direction. So we'll see. Maybe someone will start using it. I think I haven't seen as many demos of it that would really see the benefit. I also haven't seen a huge benefit of it versus all the integrations that we already have with WebRTC. And I think it will be hard to beat that. But maybe in 2 years we'll do a Quick for broadcast and live streaming second hour, and I'll tell you, you know what, WebRTC was cool, but Quick, that's where it's at.
Right. Next question.
Rian Smith in Trinidad, West Indies asks, you said hardware. Does that mean there are specific hardware boxes that can interact with WebRTC sending, receiving video, audio commands like in your demo? What examples you seen?
Go ahead, Jonas.
So the Osprey Talon encoder actually is one of those encoders that can do WIP. One of the things to keep in mind is WebRTC and WIP is still an involving protocol, as its intended purpose most of the time is the browser. You'll find that there's also updates often, there's requirements, changes, new security features that you need to implement. So it's hard to burn that really into an encoder, but the Osprey Talon has it in. Behind me, the little Minithrum MSO1, that's where we are testing our WIP wrap right now. But there's a couple hardware encoders that can do it. Most of the time you will find it's a software encoder. But that being said, even in your software, you can take advantage of the hardware encoding of the GPU. So one cool demo, for example, we had a week ago, we had Joe DeMax from
Central Control.
Central Control. And he didn't show it because it's not in core, but Central Control Connect has a really nice WebRTC view where you can see NDI sources remotely over the browser, 4K 60 FPS. And he uses the hardware encoders to make that possible. So there are advantages of using like OBS, for example, is one of the really cool integrations that we've seen that OBS now supports WIP. You just plug your URL in like a stream key and you're live, and that can use your hardware encoders, but there's not like a ready-made box for it right now.
And with the Talon, what kind of latency do you see when it goes through there?
That's a great question. I don't have a Talon here, but when we did NAB, we saw a higher latency than what I would deem acceptable for multi-views for actually cutting it. Like
Right.
for monitoring it, that's fine. I think we saw about 500 to 700 milliseconds of latency. That being said, they since released their generic WIP protocol version. So for our encoder, it wasn't out at NAB, so we had to use Dolby I/O, which Dolby I/O is great for scale. Like they allow you to say, send it out to a lot of people. I'm more concerned on latency and quality, but not as much scale. So that's like where there's a difference between like WebRTC as a CDN and how I want to use it for broadcast and live streaming, where we have like maybe most of the time not more than 50 people that need to see it that can be served by one server, but I really want to get the latency down.
And when you're talking about
probably can be faster.
And when you're talking about low latency, is that so they can interact, or is that the goal for low latency streaming?
Well, it's betting.
Betting.
When you do sports betting is when you have like the really low latency requirements, like class to class, it's 2 to 5 seconds. And the main problem is that if you have video and data feeds interacting with each other, it's really hard for them to delay the data and have it not accessible before that. So that's where a lot of those requirements for video come, because you don't want to see the data update before the video updates, which is one of the reasons why betting is so into that. Of course, interactivity is also one of those use cases that get brought up. Like for sports, there's right now the European soccer matches going on. So right now it's really funny to see who is watching what and when are they getting it, because my neighbors 30 seconds later are celebrating the goal when I've already seen it. So that's also where WIP, where that comes in.
Yeah, we were. I remember when FIFA was in Brazil. I happened to be working at a show in Moscone, and there was probably 100 yards of tech villages all the way down to do this huge event. And you could hear who was watching what, because you hear the cheering appearing at different places, throughout lunch break, typically. Next question.
Oliver Breidenbach from Boeing Software asked, to get broad adoption, there would be a need to be an easy-to-use library for WIP on all the platforms. I can't find one for Mac. Pointers.
Jonas?
I would probably look for a WebRTC library first and then add the WIP signaling on top of it. That being said, GStreamer is a common one. FFmpeg is getting integration for WIP as well. So that's kind of where you will see more mainstream adoption. Have a look at what OBS is doing. That's one of the great things with OBS having it. You can just have a look what they are doing. I think they're just using WebRTC natively and then are putting WIP on top of it, which that is not super hard to do because you need to implement the signaling at that point. There's some more advanced things like SVC and multicast and multi-streams that you could do with WIP that are a little more convoluted. That being said, I'm not super deep in Apple's ecosystem, but I'm sure there's some way for WebRTC to work there as well. Yeah, that's what I would look at. And Peon is one of the other libraries. I don't know what language you would need it in, but Peon is one of the great libraries that you can also use if you don't want to use the official Google WebRTC libs.
And what is when you say WIPs, the signaling on top of WebRTC? Can you explain that a little bit more?
So in the past, those SDPs where you describe, hey, I need H.264, I can do this much bit rate. It also includes how do you want to connect and all that. ICE candidates. This is one route that I could connect. Here's another route. In the past, you had to implement how are those messages sent to each other between two peers through a signaling server that basically both said, hey, I want to talk to this person. Can you tell them this is what I can do? And everybody did their own thing. Some do it over WebSockets, some do it over different way of WebSockets. Some encode it this way, some encode it that way. With WIP, you just send an HTTP post request and you get it. You get an SDP back. That's basically all that it is. And just quickly, because it didn't mention it in the start, WEB is basically the egress protocol where you get the video feed back. So WIP is how you send it, WEB is how you receive it.
Next question.
Douglas Carmichael asking, how are you sending the mouse clicks back to the server using WIP? From my look at the Media MTX documentation, I don't see any support for that.
Jonas?
I have to admit that's not within WIP. That was part of why would you use it? That's why we would use it. It is WebSockets directly to the tunneled instance and then TCP commands to the switcher. But WIP technically also has server-side events, and you could use it to also send data through the WebRTC data channels. But what we do is we have control separate from the video. So that way I can switch out what protocol I need for the control. I can switch out web servers and all that really easily.
Next question.
Craig McFarlane in Boston, Massachusetts asks, many WebRTC implementations don't expose some of the helpful stream quality stats. What do you use to see the stats?
Jonas?
If you are in Chrome, you can go to chrome://WebRTC internals. that tells you a lot about all the WebRTC stuff that is happening within the WebRTC. So here is what that would look like, and you can see all the different feeds right now that I have. See that for some reason LinkedIn also has a WebRTC connection open, so that's fun. And then here you can look into all the different SDPs. You see here is a pair, what it sent, all those different things. So that's what I would use. Yeah, there isn't much you can do if they don't expose it.
Next question.
Guy Cochran in Seattle asks, we want to build an SRT test page with 9 feeds displayed in a near real-time multi-view. How would we use WIP and WEP?
So what I would do is, if you look at that SRT to WEP thing that I showed earlier, you could actually use that, have all the different, have a SRT server in between where the feeds go first, and then it pulls it off. You could host 9 instances of that and then put it into something like Dashmaster that gives you all the different views back. Or you could use something like vMix, like host a single vMix instance, have 9 SRT feeds in, and then send the multi-view out. I know that you want every single one to be able to be full screenable. That's where I would use something like SRT to web. I would look at the OSS, Avon OSS cloud, just because they make it super easy to do it. They do have some requirements for how the SRT looks. For example, when I tried it with the SRT feed from Soccer, I found out we were actually sending multiple audio feeds, and they didn't know what to do with that second audio feed. So there's always still a way to improve them. But yeah, that's what I would do. What we also do for our own infrastructure is all SRT feeds hit Nimble, streamer in the cloud, and then they get NDI outputs. But also for engineering, there's a WebRTC output. So each of our encoder endpoints produces an NDI that then gets used in vMix. But then it also produces a WebRTC output that you can put on a website. We have it on our encoder management side where you can see all the encoders, where you see all the SRT stats. Yeah, those are a couple options, but a lot of the media servers like Media MTX and all the others do actually support SRT in, and Media Server does it. Can't think of the other one. Also,
but it would cost like what, like $100 for that Nimble transcoder to be able to take the SRT in.
For NDI, Nimble you would pay $120 to transcode it, because you would probably per month. But you can also use Media MTX, like I said, or any of those others, and host it on. I know you like your Macs in the cloud. You can put it at Mac Stadium, run it something there, or run 9 instances of that SRT to web there. And Media Server does it. Can't think. Oven Media Engine is a free one that also does SRT to WebRTC. It might not be web, but that's options that I would look at.
Next question.
Rion Smith in Trinidad, West Indies asks, I would love to find a diagram or document showing a WebRTC, SRT, or TMP diagram that helps us protocol noobs understand which is best to use in different situations.
Seems like one of those, like SMPTE and some of the other ones build these, BAFTA makes these incredible diagrams of all these different things and how they all work. But there's a team that does that, and they spend a year working on them. So I think that we need to, but I do think you're right that figuring out maybe some PDF or some poster that you could put up that would tell you all the protocols of how they get through and what it takes to do it would be an amazing project to work on. We just have to think about how that would get done when we can say yes.
Yeah, I think that's a great idea and something that I probably should look at to do. The general gist is WebRTC right now for us is viewing protocol. We have played with using it for contribution as well, but that requires more end, especially like I use it right now when I can control my sender and I know a lot about the infrastructure. SRT really is great when you have you don't really know how the network is. You know that you want to be prepared for bad weather days where you need to deal with packet loss, high jitter, and problems like that. You want to send multiple MPEG TS feeds into it. So like multiple programs, multiple videos, multiple audios, for example, what we did with soccer, where we sent 2 channels of English and 2 channels of Spanish. That's something where SRT strives because it's like in the MPEG TS spec. So all of that you know from there, you can do with it. It also helps you like repackage it for like more traditional internal distribution. Then RTMP right now is the protocol that everybody uses to do the final delivery and code into the CDNs. So I wouldn't use it if I need to. The one point where I would use it if I need really low latency and I have like a strict requirement that I need to encode with like 3 Mbits, and I have 3.5 Mbits only of upload bandwidth, I would probably actually use RTMP instead of SRT, because SRT will always have an overhead of at least 20% is what you do base as the baseline, and that is just, it needs more bit rate, or it needs more bandwidth with the same video bit rate to allow all those cool features that we love, like dealing with the packet loss, dealing with the jitter. So yeah.
Makes sense. Next question.
Another question from Rion Smith in Trinidad, West Indies. Do you feel space comms could be done via a WebRTC and in the near future to give maybe a video viewer as well?
So space comms already uses WebRTC. That's one of the that's basically the protocol that we use for all the communication that allows us to be in the browser, that allows us to have the low click-to-talk latency, where you don't need to wait because we actually don't require any of the typical centralized mixing that you would find with typical matrix intercoms. That being said, yes, WebRT, you have seen how enthusiastically I am about getting my multi-views over WIP and web. So yes, web viewer in space comms is definitely something that is in the planning. Till then, what you also can do, I'll put a link in the chat to embed multiview.watch, where that's what we use to embed all our web views. It's basically a website I built that you can just put your channel URL in, put the full web URL in, and it just renders it for you. We use that with Dashmaster to render it in an iframe, but you can use it for whatever. And yes, it's definitely something that we're planning on doing.
Next question.
Guy Cochran in Seattle asks, can you summarize your LinkedIn article and some of the replies?
Yeah, I think summarizing. It already was a really quick summary of the last 40 minutes of talking, probably. What was interesting is you see a lot of people being like so happy that there's new people coming into the WebRTC field and that we all can suddenly talk to each other. Like in the past, there has been a lot of issues like, okay, yeah, we'll implement your specific WebRTC spec for this thing. But then someone else comes in and you would need to say, yeah, well, we support WebRTC, but only if you do signaling this way. And only if you do it this specific way. That is no longer the case with Web. There's still some specifics that you sometimes need to figure out. But now, like, for example, I have OBS, send Cloudflare stream. Then I can have Media MTX, pull the web feed from that and serve it over a whole CDN again. And then I can use my web browser to just look at it. Like all those pieces just flawlessly working together. That's the thing that I'm most excited about. And that's kind of like where that article was. It was a primer to help people who don't want to work the nitty-gritty of implementing it know, why should I even care about it? And why, like, what is it? What can you do with it? And why do I think it's going to be such a big thing in the future?
Next question.
Roscoe Jones in Madison, Indiana. Does WebRTC suffer from ossification, network protocols becoming hard to modernize? How will WIP avoid this issue if it can be avoided?
Well, it's interesting. WIP really is only the signaling. And one of the biggest feedbacks that I got from the article is like, oh, by the way, technically you can also do this. One of the things I tried with the article is to be realistic about what exists right now. But there's so much things that you technically can do with WebRTC if you control both ends. WebRTC really is still evolving pretty fast. Like I don't know if it's a year already that it has been out and as a spec, but one of the cool things is that since we're using the SDPs and it's not like a specific protocol, it's like, how do I transfer those SDPs? You can write whatever you want into those SDPs. Like I said earlier, 2110 and Dante also use SDPs. So that should give you some idea and food for thought that you can do whatever you want. And WIP will just help you communicate those SDPs to each other. That being said, I do think that that's always a problem, but also at the same time is kind of also a sign of success, right? When you have so many vendors using it, that it's starting hard to be there. But in the end, one of the cool things with it being on the HTTP spec is it is also really simple to version. Like you can do a /v1, /v2, /v3. You can add query parameters to it. You can do all those things that we know from HTTP that should make it easier to manage it in the future.
Jonas, thank you so much for coming on and introducing it. One of the things I love is when we have folks that are members that are highly technical come in and get us ahead. Have us looking down the field and seeing something that is just kind of picking up speed and having us kind of on that front edge. So I just really appreciate the time you took to come on and explain this to us. And thanks to the rest of the panel for being here for the first hour and second hour. What a dense day. So we had a lot of great questions and answers in the first hour, incredible second hour. So just really good day to be here. And but thanks to the panel, we can't do this without you. Thanks to to all the producers who asked all the great questions that kept this day moving really, really fast. And thanks to the incredible development team on the back end that Jonas is part of, and many others that helps build what we do, execute what we do, plan what we do. All of those things take a small village to do every single day, and we appreciate the contribution that all of you make to making this possible 7 days a week. We traveled the Tlaloc Traversal. If we had to wander around and ask these questions person to person, we would have traveled 95,000 miles. That's 153,000 kilometers, and that is 753 million bananas for scale. All right, let's go ahead and jump into After Hours.
Thanks, everybody. Yeah,
that was good.
This is fabulous. I came away feeling a tiny bit smarter than I was when I arrived here today. That's fabulous.
I just feel like there's a Devo song in here somewhere about whipping it good. Whip it.
Whip it into shape.
Whip it good.
Yeah.
Do we have to wear flower pots on our head to come on the panel?
If I thought about it just a little harder, we would have got like some kind of synth version of that to throw at the end.
Dear ChatGPT, write me a parody.
Yeah,
yes.
Yeah. What were you going to say, Jonas?
Every time I talk about whip, like there's this Watch Me Whip song that just automatically starts playing in my head, and it's so annoying.
It's got to be
the brain is so strange.
I was having a hard time without it. I was having a hard time without thinking, whip it good, and there's whatever.
That's a cool whip.
That's the ad though. That's the Devo. Now you probably haven't even heard that song, Jonas.
No.